So the Brainfuck language is a very simple language, and I've demonstrated how the language works. So basically, you're given a tape of 30,000 cells, all initialized to 0, and you're also given access to a pointer. And you can manipulate these 30,000 cells with the following 8 commands. So the left and right commands basically allow you to move your pointer left and right to the cell. The plus and minus commands allow you to update a cell. So from 0 you can add 1, or you can decrement a cell from 0, and that'll set it to 255, since these numbers are all 8-bit numbers that overflow. And if you hit the dot or the period command, it'll output the value of the cell as an ASCII character using an ASCII table. The comma will accept user input, so 1 byte of user input, and store it at the current cell location. And these two are just loops, so the loop basically will run until the starting cell is 0, and then it'll skip. So if we have a loop of, say, this will run indefinitely, since you're basically saying as long as the starting cell isn't 0, this will run indefinitely. But if the starting cell is 0, or say 1, then it will run indefinitely, since you're basically saying move right until this cell is 0. And since you never actually have code to set this number to 0, it'll run forever. But if we have some code, say go left, go right, and then minus, and then repeat. If say this cell was 3, then this would enter the loop. Since this cell is not 0, it would move left, move right, and then subtract 1. So this would become 2. Then it would left, right, subtract. This would become 1. Left, right, subtract. This would become 0. And now that this is 0, the loop is over, and we move on to the next instruction. Let's say it was a right instruction, then that would move your pointer right. So those 8 commands fundamentally make up the Brainfuck language. So it's actually a very simple language, and it's relatively easy to implement. So first, let's use std error so that we can make the main function return a result of unit and box dime error. Basically means this function, the main function, will return a result, and if it returns an error value, it'll be something that implements the error trait from std error. So first, let's make a script.bf. So this is just some Brainfuck code to print out hello world. So let's use std fs file and io buff read and buff reader, so we can actually read the file. So let's make a reader, which is going to be a buff reader new that wraps around a file, which we will open. Call it script.bf, since that's the name of our Brainfuck file. And then, since file open returns a result, we can use the question mark operator to just push that error. Since the IO result is the IO error implements the error trait, we can just pass that up using the question mark operator, and it'll work fine. So now let's make our tape, which is a like 30,000 like vector of zeros. And then let's make our pointer, which will start at 0. And we need to make the tape mutable. So mut. Okay, and let's let the code. It's going to be a vector of characters. So it's going to be reader.lines.map while result : okay, so while result.lines produces a okay result, so while it doesn't produce an error, we will flatten and map. We'll take the line, which is a string, and we'll just collect it, line.chars.collect into a vec. Use the turbofish to make a vector, and then we collect that. So since we're turning each line into its own vector, we need to use flatMap to flatten this vector, so we only get one vector and no nested vectors. So now let's do let position equals 0. So this is just our position. And then we can do while position is less than code.len. And the reason we're using the position, a different variable for the position and pointer, is when we're dealing with loops, the pointer and the position aren't necessarily going to be the same. So we just need different variables for that. So now we'll match on the code at position. So now we can use those rules as before. So if we get a write operator, so we increment the pointer by 1, and if the pointer is greater than or equal to the tape's length, then we just set the pointer equal to the tape's length minus 1. Now for the left operator, we just pointer dot saturating sub 1. So what saturating sub does is basically make sure that if pointer is 0, then instead of overflowing, since pointer is a usize, instead of overflowing, it'll just stay at 0. Now for the plus operator, it's also pretty simple. We just assign the tape.pointer equal to the tape at pointer. Oh, forgot a arrow. Just set dot wrapping add 1. So like I said before, each value in the tape is will wrap around, and so if it's at 255 and you add 1, it'll go to 0, and if it's 0 and you subtract, then it'll go to 255. So similarly, with if we get a minus, and we'll just do tape at pointer is equal to tape at pointer dot wrapping sub 1. If we get the dot, then we will print the tape at pointer as a character, which means that this should be 0u8 to make sure our vector is of type u8, so we can cast it as a character. Then if we get the comma, we need to output the current cell as an ASCII character. Or sorry, that's if we get a comma, that means we need to accept input from one single byte of input from the user, and we set the value of the input to the current cell. So let mut input equal string : new. And we do tape at pointer is equal to, so the tape at the current pointer is equal to IO. That means we must import IO. So IO std in dot read line, and our buffer is going to be a mutable reference to our input, which is a empty string, and we will unwrap. We don't actually need to unwrap, since I believe we can just use the question mark operator again. And then we do input.trim.chars.next.map or 0 C as u8. So what this does is basically takes the entire input, turns it into a list of characters, and grabs the first character. So that way, if the user inputs multiple, it'll only grab the first. And this map or is that if the character is invalid, then it'll just default to 0. Otherwise, it'll take that character and cast it as a u8. And so after this, we just need to increment the position by 1. And that's mostly it. So now we just need to add some extra logic for loops, since loops is slightly more complicated. So this isn't the most optimal solution, but the way I figured out, or how I did it, was I made a jump table, which is basically a hash map. So we need to import collections : hash map. So it's basically just a hash map of positions. So it would map a number to another number, which is basically a position to another position. So we can map the say start of a loop to the end of the loop, like their positions. And we also use a let mut DAC, which will basically store basically a vector to store the intermediate positions of all of the loops. This is just so we can support nested loops, which most Brainf programs use. So we'll use for I and C in code.iter.enumerate. So iter.enumerate will basically give us the character and the position of the character. So we'll do if C is equal to a opening bracket, then we will push the position of that bracket to the stack. Else if the character is equal to a closing bracket, then we will check if the start of the if the start position of the corresponding opening bracket is in the stack. And if it isn't, that means we have an unmatched closing bracket. So we'll return an error of unmatched closing bracket, and we'll call dot into to convert it into the box time error. And if we do get it, then we will insert the jump table dot insert. Key is going to be start and I, and then we're going to insert, and then we're going to insert the opposite, I and start. So this first start I is going to be if we're done with the loop. If we're finished with the loop, then we want to jump to the character after the ending bracket. And this one is so to continue on to the next iteration of the loop, we want to jump from our current position to the start of the opening bracket. And then after we do this, if not stack dot is empty. So if the stack isn't empty, which means we have uneven numbers of pushes and pops, that means we have an unmatched opening bracket. So we'll just return an error, unmatched opening bracket, and then we'll call dot into. So you can see this isn't exactly the most optimal, since we're iterating over the code twice. So here once to populate the jump table, and again to actually parse all of the instructions. So if the program is so right now this program is really short, so it's not that bad. But say you have a program that's very long and compute intensive, uses a ton of loops, then this definitely isn't the most optimal strategy. But now we can use loops. So if we encounter a opening bracket, so if tape at pointer is equal to 0, so how a loop works is that if the starting cell is 0, then the loop is finished. So we want to set our position to the jump table dot get our current position dot unwrap, since this key is always going to be there since we've already iterated over the loop. And then a really similar thing for the closing. So if the tape at index of pointer, I can't spell, pointer, is not 0 this time, so if it is not 0, then we want to set the position to jump table dot get and position dot unwrap. So this will basically, so if the loop is not finished, then we want to jump back to the start of the loop. And since jump table dot get returns a reference, we want to dereference it. And then for all other characters, we just want to do nothing, since any characters other than these 8 in Brainfuck are just treated as comments. So that should be it. If we don't have any errors, oh, we do. Okay, so oh right, I added a semicolon. We need to return this value, and then here we need to assign the pointer saturating sub. Okay, yeah. And so that should be it. So let's run cargo run. And yep, we get a hello world program. And so now just for fun, oopsies. Now just for fun, instead of this simple hello world program, I have this program to calculate the Mandelbrot set in Brainfuck. So I'm not going to pretend like I understand any of this. but apparently it's supposed to calculate the Mandelbrot set. So let's try it. If I can open the terminal, please. Okay, thank you. So I'm just gonna run this with release since just ignore this autocomplete, but I'm gonna run it with release since when I tried it with debug, it takes a really long time. But yeah, so this code will print out the Mandelbrot set in Brainf. In Brainfuck. So this code isn't the most optimized. In fact, it fits in under 90 lines, even though it isn't optimized at all, which just goes to show how simple of a language Brainfuck is. And of course, like I said, there are definitely optimization gains to be made here, like removing redundant instructions. Like, for example, this instruction, so like move right, move left, add, subtract. This like simplifies to nothing. So there definitely are optimizations to be made, but this is like the simplest and easiest I've done to get working. So yeah, I hope you guys liked this little tutorial on how to make a Brainfuck interpreter in Rust. All the code is going to be on GitHub, so if you want to make any optimizations or anything, feel free to make a PR. But yeah, I hope you guys enjoyed, and see you in the next one, I guess.